talk about some of the standard projects, which is the ones coming up are 105 and 102. So let me talk about them. 105 is Process Explorer. So I'm just going to shove the instructions to the side so I can refer to them while doing it. All right. So we're going to make a program here in Visual Studio. So you go to V for Visual Studio, and we're going to use the developer command x86 native tools command prompt. And don't know if I already demonstrated this one in this class. If I'm repeating myself, let me know. I've been teaching so many workshops, they kind of run together in my mind. Anyway, so you make a directory, C:\99. I think I'm going to find it already exists. Maybe not. Then you go there, 99. All right. And now we're going to do Notepad of 99.cpp, writing a C++ program, although actually I think I might actually be writing C anyway. Now this one's really C++, okay. I get them mixed up, and you can give them the wrong extension and it works. So here's the program. This is just going to include IO streams, so I have input-output functions, and it's going to print 99 bottles of beer on the wall. And then press enter to continue, so it's not going to just end and terminate, it's going to pause, waiting for the user to press enter. That's all it's going to do. So this is a very simple program, just prints a couple lines of text. So we save that, and now compile it. We can just do cl 99.cpp to compile it. That will compile it, turning it from a C++ program into an exe program. And if you do a dir, you'll see it actually took the C++ program and created something called object code, which is an intermediate structure, and then it used that to create the exe, which, as you can see, is a whole lot bigger, 104 kilobytes to an exe. And if you run that, it prints a couple of lines about beer and then pauses until you press enter. All right. Now we're going to examine that running process. So I'm going to run it here. And let me see if I have to compiles and runs. Right, just do it right here. So I run it here. All right, and now we're going to examine how that running process looks in Process Explorer. Process Explorer, EXP, there it is, Process Explorer. All right. Good, and here is Process Explorer. Process Explorer lets you see what's happening on your machine right now. It is the souped up version of Task Manager. And it loads things in the order in which they started, or at least something close to it. So first, the system boots up and it loads the registry, which involves probing the hardware to see what devices you have and such. Then it starts the system. Then it starts Windows with WinInit, which is analogous to the Linux process init that starts the operating system. And by the way, the indentation shows you what is the parent and what is the child. So WinInit is the parent, and this thing called services is a child, and SVC holds a child of that. So it starts Windows services running, and then it starts things like Runtime Broker and Skype and all this jazz. And then it starts a whole bunch of these pink SVC host things. Those are the services running in the background. This all happens before you log in. So if you hover over them, it tells you what they are. This one is the Network Connection Broker, and this one is the Time Broker, and so on. These are all the background services running in Windows that all happen before you log in. And there's Splunk and Sysmon, which are things I added to this system. And way down here is WinLogon. So it did all that junk just to get going, and then it presented you with a logon menu. And when you log on, it now launches Explorer.exe, and Explorer is the process that draws the start button and the desktop. And everything you do, from the start button, the desktop, the command prompt, is a child of Explorer. And this is called Userland, all this purple stuff. These are the low-privilege programs that do not have the ability to directly touch the hardware. The only programs that can touch the hardware are all these programs up here in kernel land. And so if your program wants to print something on the printer or put it on the console, it's not authorized to do so. It has to make an API call to call a library up here in kernel land, and that will do it for you. You are not authorized to directly touch the hardware. And therefore, when one of these programs crashes, it doesn't kill the operating system. The fundamental operating system continues to run, and just that one program dies. But if the kernel dies, the whole machine dies with a blue screen of death. So Microsoft doesn't really like amateurs writing code that runs up here. They would prefer those to all be Microsoft programmers, or people that write device drivers are supposed to clear them through Microsoft first to get the bugs out of them, because things that crash up here kill your machine dead. You're supposed to stay down here in user land, where your buggy code will only crash itself and not kill other programs. So here's the program we just wrote, 99.exe. It's a child of conhost, which is a child of CMD, which is a child of Explorer. And there it is, and you can learn more about that program by right-clicking and going to Properties. And here you see various tabs. The most fun one is Strings. This will show you the readable strings in the program. So you notice this always has this program cannot be run in DOS mode. Every program always has that. And then it has the name of the sections, text, rdata, .data, and so on. Then some random junk. Then if you scroll down here for a while, I guess I can go down a page at a time. There we go. We see lots of random junk. Then we're going to see Windows API files, references of libraries or something. I'm not quite sure what these are. There's some kind of low-level thing. Then we see the days of the week, and for abbreviation spelled out, the days of the month, the months of the year, and so on. That's some kind of library having to do with calendars or something. And then a list of all the language abbreviations for all the language Microsoft Windows supports. It supports all commercially viable languages. So there they are, abbreviations for all the languages that this program could run under. And then we have some more low-level functions. And here's the actual strings that the developer put in this program. 99 bottles of beer, press enter to continue. So the strings you type in are just sitting right there in memory. They're loaded into memory. Now what you're looking at right now is the strings in memory. And if you click, this is on the hard drive image. If you look in memory, you click memory here. But you'll see they're just the same. This program cannot be run in DOS mode, text, rdata. Then down here you got those Windows API things. Then you got the days of the week and the months and all the languages. And pretty soon you got the 99 bottles of beer stuff right there. So if you were to write malware and you put something important in the malware, like the domain name of your command and control server, then you can't, it's going to be just sitting there right on the disk in the compiled code and in the memory. Now there is an attack called process replacement, where you take running code and you change the memory of the running code. And in that case, you'll observe that the memory and the image have different strings. This is a normal program where it just copied what was on the disk right into memory and ran it. All right, let me see if there's anything else I wanted to say about it here. Nope, that's it for that one. All right. So that's the joy of Process Explorer, just let you see what's running. By the way, another thing you can do is you can view lower pane view, show lower pane, and then it will show you the libraries or the handles. So here you see the these are, I think, handles. If you do view, lower pane view, there's the libraries. Here it will show you what libraries are being used by this program. And there they are, kernel 32 and such is the libraries. Every program pretty much uses kernel 32 so it can touch the hardware. And then WoW64, these are the libraries used by 32-bit code running on a 64-bit operating system. This is Windows on Windows, WoW. This is like a little virtual machine, so you can run 32-bit code on a 64-bit processor, which is what's happening here because we launched the 32-bit x86 native tools command prompt. So we compiled this into 32-bit code and then ran it on a 64-bit OS, which, by the way, you cannot do by default on Linux. You have to load special libraries, but Windows always includes by default the ability to run one generation back. So 32-bit Windows can run 16-bit code, and 64-bit Windows can run 32-bit code, because Microsoft is all about supporting old stuff, because a lot of businesses have got old stuff, like from 10 or 20 years ago, old programs and old hardware on their network that they're still using, and Microsoft is all about supporting that as long as it's valuable to companies. All right. So I'll stop that one.